Once again, thank you very much for joining us today. There have been many tech talks that Mirantis have run in the recent past. Today, we'll be talking about connecting Kubernetes pods to legacy workloads using Cilium Egress and Gateway. First of all, I'd just like to introduce myself. My name is Atwell. I'm a solution architect at Mirantis, previously at Docker. So I specialize in the Docker and Kubernetes workloads that we help our customers run on our platforms. Waseem, quick introduction, please.
Yes, my name is Waseem Swadi. I'm pre-sales solution architect working with Mirantis for almost 2 years now. And I used to work a lot in telcos with some vendors and operators across Europe.
Okay, so let's look at today's agenda. What we'll discuss today is the problem statement at hand. So, connecting legacy workloads to cloud native containers and pods. Some of the issues with the native egress Kubernetes that comes out of the box with Kubernetes and the limitations, any security challenges that exist therein. We'll talk about how to overcome those particular issues using something like an Egress Gateway, and then we'll quickly discuss and go over the differences in topology there, but very, very high level overview. So we won't go into too much depth regarding the actual CNI or the egress solution itself. I'll then pass over to Waseem, who'll then go through a solution overview, demo the solution. We'll have a quick recap, conclusions, and then we'll obviously be available to answer your questions. As I said, the bottom right-hand corner, there is a Q&A window, and we will get around to answering your questions, but towards the end of the session today. Okay, so quick introduction. So obviously in a perfect Kubernetes world, a cloud native world, you only really need to worry about the types of workloads that are running inside your cluster itself. But as we all know, in enterprise organizations, the reality is that you need to connect these workloads that are running within Kubernetes to external physical networks or clouds, basically workloads which are running outside of the cluster itself. So as prime examples here, things like databases running on a physical network, or for example, an Nginx web server running on a virtual machine. And that's what we're going to talk to you about today. And then we'll show you that live, or Waseem will show you that live. So please hang around, and I hope you enjoy the next 30 minutes or so and you find it useful. So what do organizations have today? They obviously run cloud native workloads. More and more organizations are coming on board with cloud native, but they also obviously have legacy workloads within their organization that they need to connect to. And that connection needs to be as secure as possible, without any loopholes, without any method or any way for rogue actors to obviously penetrate, through your networks into your legacy workloads, for example. So what do organizations typically want? They want a zero trust control flow between your cloud native pods, so your Kubernetes pods that run containers, connected up to your legacy virtual machines. And they also want, and this is what we hear throughout the industry, is they want a solution that comes out of the box. So whether that's open source or whether it's part of a CNI that's sort of that's delivered out of the box. Now, as we know, so egress and ingress is managed through Kubernetes network policies and the APIs, but it does have its limitations. Okay, and some of those limitations we're going to discuss shortly. But just to sort of keep in the back of your minds, as we know, pods and node IPs are ephemeral. Therefore, sort of dealing with pod IPs and node IPs in an enterprise becomes a challenge, and it can lead to sort of IP exhaustion as well. The default solution, and we'll come on to explain this in a little bit more detail. Using the network policy, you have to allow the full pod CIDR range to have access to a production database, is the example that we're going to take you to talk through, shall I say. So that obviously can and does pose security issues. So just to summarize, as more and more organizations embrace containerization, adopt Kubernetes, although they reap the benefits, from platform scalability, application portability, and optimization of the infrastructure itself, with this shift comes a set of security challenges which we really do need to address. So the challenges are really related to connecting, applications within a heterogeneous environment. And that's what we're talking about in essence today. So let's look at the Kubernetes native egress, which is based on a network policy. So the network policy resource provides a way for us to define the controlling of both inbound and outbound network traffic within a Kubernetes cluster. And that's the key thing, is within a cluster itself. The network's policies themselves are application centric. So what you do is you specify how a pod is allowed to communicate with various network entities outside of services, external network entities such as services and endpoints, I should say. So as I said, the network policy is applied to both ingress and egress. There is an ingress resource, and a native ingress resource, or a kind as we know it in Kubernetes, but you don't have something similar for egress. So yes, unlike ingress, egress traffic is not controlled by any standard Kubernetes API or proxy. The default method of handling and managing egress traffic is through a network policy. And when you actually define those policies, and hopefully we shed some more light on this throughout the presentation today, is that when you create them, you actually define the policies themselves based on IP blocks, which is basically CIDR ranges, and that's the cause and the cause of the actual, well, most of the potential security concerns that could pop up. So by default, what happens is the traffic that's leaving a pod will follow the default route of the node, and will get masqueraded, what we call S-NATed, to the address or the outgoing interface of that particular node itself. And to that end, there are obviously some known limitations that do increase the attack surface area. And one of those limitations being that that network policies only works for traffic within the same cluster, which I mentioned earlier. And the other fact is that with network policies, the connection only applies when you have a pod on one or both ends, and not relevant to any other connections therein. So if we look at the example here, so we have some Kubernetes YAML, and what we have is a network policy that shows or contains, shall I say, a single rule for egress to a backend database. So you can see that we have a database, and we're using port 5978. And what the rule will do is it will match traffic on that particular port to any destination in 10.0.1.0/24. What this does is if any pod within that particular CIDR range, the 10.0.1.24 /24, I should say, if any of those pods are compromised by any malicious actor, then the database server that it's connecting to could be exposed to that particular malicious actor. And these are the security concerns that we're referencing throughout this, session today. Some more limiting factors of a network policy are obviously listed there. I'll go into a little bit more detail. So it does have, I should say it's limited to layer 4 filtering. So what I mean by that, so the network policy operates at that layer 4, the transport layer of the OSI model. It provides basic filtering based on IP addresses and ports. So you don't really have native support for things like filtering based on certain protocols, such as HTTP, as an example. The network policy is pod-centric, so it does take a pod-centric approach. So the rules are defined at a pod level. And this basically means that any policies that are applied to every container within a pod. As we know, you can run more than one container within a pod. Again, this is potentially a security risk. They're also tied to namespaces. So, the network policy rules are enforced at the namespace level. So this means that any egress policy can only be defined and applied within the same namespace. And you can't have global egress policies that span multiple namespaces. So again, another limitation there. External network visibility. So again, it's limited. So the network's policy itself within Kubernetes is not designed to enforce any egress policies for traffic leaving the cluster and reaching external networks. So if you need to apply more aggressive egress policies for traffic leaving the cluster, you will need to rely on some external network infrastructure such as firewalls or network gateways such as an Egress Gateway, which we'll talk about on the upcoming slides. And obviously limited observability, right? So you don't get any observability out of the box. So there's no extensive built-in monitoring, logging, and capabilities. And that really can make it very challenging to gain visibility into egress traffic and diagnose any issues that may be network related. Okay, so we have a picture here that sort of denotes some of the challenges that we experience. So in Kubernetes, by default, NAT egress packets to the NAT egress packets to the interface of the IP of the node, should I say, which exit the cluster. So what we're saying here is that we have NAT outgoing set to true, which is the default. And if we consider this particular example in the picture there, the example itself is permitting connectivity to a backend database server, as we can see at the top. So to enable that access, the security admin must allow the entire node IP CIDR, so the 10.0.10/24, access to provide access to that backend database server. So in doing that, what that does, it permits connectivity obviously to the database server, but from any pod, from any node within the CIDR, because it's any node within the cluster, I should say, because obviously it's node specific, and you're passing the whole IP, the node IP address. So in our example, we have pod A in blue, and that requires connectivity to the database server. The node IP CIDR must be allowed listed, as I said, by the firewall, by the network firewall rule, which inadvertently grants access to pod X. So if pod X was compromised, then obviously this could expose the database server to this rogue actor. Okay, you can disable NAT outgoing, so you can set it to false. And what that does is it retains the IP address of the pod that initiated the session itself. So in this particular scenario, as we know, pod IPs in Kubernetes are ephemeral. The network security admin really doesn't or needs to allow the entire pod CIDR to enable connectivity to that backend database. So in both these scenarios, you require overly permissive firewall rules, which really does increase the attack surface area and risks non-compliance. And hence, we need this alternative solution to the limitations that we have in native Kubernetes and the native egress that's available within Kubernetes. And that's not to say that we don't have, or Kubernetes network policies are not valuable. I mean, they certainly are. But they only enforce, a very basic level of network policies within a cluster itself. Hence, with the need for, more advanced traffic management and control for more complex requirements. So, having discussed some of the limitations and some of the issues and security concerns, what is the solution? So, I mentioned Egress Gateway a couple of times, and that really is another approach and a sort of, should we say, more adopted approach now to manage egress from Kubernetes, especially when you're connecting to backend legacy workloads. And that can be done by one or more egress gateways. So you don't have to have just the one. You could have multiple egress gateways within your cluster as well. So an egress gateway is implemented through the CNI, and the CNI egress gateway is really just a networking component that's used, obviously, in containerized environments to manage outbound network traffic. And it basically creates a bridge between the container network, should I say, and any external network, allowing obviously, multiple communication across those networks. Excuse me. The egress gateway itself does serve as central point for routing and controlling outbound traffic from containers. So typically what it does, it provides features such as, NAT, load balancing, security policies, and traffic shaping. The policies, the features, shall I say, themselves, enable administrators to basically control and secure outgoing connections from containers to legacy workloads, but ensuring compliance across the network, and ensuring obviously you have a good security posture. And then finally, sort of by utilizing, a CNI Egress Gateway, organizations can really monitor and manage outbound traffic as well. They can do that more effectively. They can apply security measures, enforce policies, and route traffic through specific gateways or proxies. And this basically overall enhances the network security, as I said, and the security posture, of your cluster and connectivity to backend workloads on running on virtual machines, for example. Okay, so a little bit more about an egress gateway. So as we know, and I said, and I've mentioned many times, egress is required in situations where a pod needs to communicate securely with legacy workloads. And obviously, it makes sense to do this either via an API gateway or alternative, without, should I say, allowing direct communication between the two, which again can be a security risk. Gateways allow you to configure the source network address translation so that certain egress traffic from your cluster is given a more predictable IP, and that helps with traceability across across your networks as well. So from a traceability perspective and troubleshooting perspective, it's a lot easier to actually manage when you're deploying egress gateways. As I mentioned earlier, egress gateways are not a native concept of Kubernetes themselves, but are implemented with some Kubernetes network implementations, such as a CNI. Could also be things like service meshes as well. Again, we won't delve into service meshes. This talk today or service mesh egress gateway. This talk is all about, the CNI egress gateways. So there are a number of security reasons that you need to keep in mind, should I say, to connect to legacy workloads. And sort of, egress gateways really help you manage that. So the redirection is done through the gateway, and that redirection could be a subset of Kubernetes nodes. It could be Kubernetes pods, for example, or external nodes. And that does totally depend on how the CNI provider or vendor actually provides their solution out of the box for egress gateways. So as I mentioned earlier, the redirection could be at the application level, so using service mesh egress gateways, or alternatively at an IP level, so where we're talking about egress gateways, such as the Cilium Egress Gateway that we'll talk to you about today. Just coming back to service meshes, most service meshes, if not all, will provide some API gateway functionality. Having said that, we still need to allow for pod-initiated external communication without the need of a service mesh and without the needs of the complexities of actually implementing a service mesh itself. So as we've learned, when a pod sends a packet out of the cluster, the packet is source network address translated with the IP address of the node where the pod is running. So in the example here, this is direct access via a local node. So this is without an egress an egress gateway. Here we see, the pod IP 32768 is SNATed via the via 49152 and 60998. However, when an egress gateway is in place, you can actually specify certain outbound packets, or which outbound packets should be sent to the dedicated gateway node first, and then out to the network itself. So this is what we see on the right-hand side here. So when a packet has been selected, to use the egress gateway, the packet leaves the cluster from node 1 in the right-hand example here. The packet leaves the cluster from the gateway node and is SNAT translated with the egress source IP that is configured on the network interface of the node itself. So on the right-hand side, in both these cases, the end result is the packet does leave one of the Kubernetes nodes SNATed to the address of the egress interface itself. And obviously the reverse of that is DNAT, obviously used to transparently change or used for transparently changing to say the destination IP of any routed packet and performing the inverse function for any replies. So obviously works in reverse. So you get that full traceability. Yeah, perfect. So I'm gonna be quiet now, and I'm gonna pass you over to Waseem, who's then going to talk to you about the solution that we've implemented here and take you through a demo. I'll stop sharing, Waseem.
Okay, very well. Yeah. So all that you need in order to replicate this setup is some virtualization solution. So we did work with Mirantis OpenStack for Kubernetes. Is our OpenStack so basically a solution. This is based on open source. We used basically Ubuntu. You need a recent enough Ubuntu because, as you know, so we will be using Cilium, and this is using eBPF. So you need something quite recent, right? And we used Mirantis Kubernetes engine, but you could use any kind of Kubernetes, right? Like vanilla Kubernetes would do very easily. And then we used Lens as well. Lens is a tool that would help you to view and operate any kind of Kubernetes distribution. So this could be MKE, or it could be Rancher or K0S or whatever. So again, this is only to facilitate so the job. You could use like some other tool or only kubectl only. And we use, of course, like we use this Cilium as Egress Gateway and Helm chart and Nginx. So let's move forward. So basically, this architecture is coming obviously from Cilium, as you could see. So basically, we will have our Kubernetes cluster. We will have an Egress Gateway, which is one of the nodes of this Kubernetes cluster. We will have our firewall, which would be represented by a security group in OpenStack, and we will have our legacy VM, which is basically a VM on OpenStack. So in order to get more details, so this is our high-level architecture, right? So we have a certain amount of VMs that we created on OpenStack. So as I told you, you could do that in some ESXi's or whatever, or even locally. So this would represent our legacy. So yes, right. It's here where we have our databases, where we would like to access them from our Kubernetes cluster, right? Here we have a Kubernetes cluster with one manager and three basically workers, as I will show you later on. And then we use basically Lens and other tools in order to connect to this containerization platform and this virtualization platform. So please don't be confused by this layer 2 architecture. This is not the idea. So here I just want to show you some IPs that I would like to stick in your mind in order to understand the demo, right? So basically here we have our Kubernetes cluster. This is a normal classical Kubernetes cluster, as I told you, with one master and with three workers called worker 0, worker 1, worker 2. And then we have one DB, right, which is on an external network, as you could see here, where between this DB and our Kubernetes cluster, we have basically a firewall. Now, this is not really a firewall, it's some security group on OpenStack, but it is also used in order to open, close the specific flows. So the demo would start by so basically sending traffic from worker 0, worker 2 to this VM, where we don't have any security group in place, meaning that when we send traffic from the worker 0, we will see the IP.26. When we will send the traffic from worker 2, we will of course see the IP.65 as explained by Jas, meaning that the workload is outcoming, which is NATed through the IP of the worker itself, right? And then we will activate the Egress Gateway, which will be this one. And we would activate the firewall, which would be this one. So let's move on. Yeah, so basically here you have 3 different windows, right? You have this one, in order to show you the architecture, the IPs to keep in mind, worker 2, worker 1, worker 0, and the VM, this one here. You have here, this window here, where we have access to our VM. And inside this VM, we will just, so we will display actually the logs in order to see who is communicating with this VM, right? And here we have basically lens. So if you do not wish to use lens, you could use only like a kubectl commands. So I will do some kubectl commands anyway. So in order to show you how to replicate this at your end. So basically here with Lens, which is a tool that you could leverage now, like download a test, you just need to add your kube config. And once you added your kube config, you have basic telemetry. So basically here, we see that everything is fine, CPU is fine, memory is fine, the amount of pods are fine, and we have no issues, right? We have our nodes. So as I told you, we have 1 master and 3 workers, right? One of these worker is having specific taint, right? Why? I think that you guessed, because this worker would be used as an Egress Gateway, meaning that I don't wish to put any kind of traffic on it. I would like to dedicate it only as Egress Gateway. So now, as we could see here, we have no pods. And let's see, so our Cilium. So Cilium basically is deployed through Helm chart. We could see it here. We could see it here in this namespace. Basically, we have Helm chart. So if we would like to wish how it is configured, so we could display the CRD. So basically, you could see that the configuration is quite straightforward. We have only, so of course, you have multiple ways of configuring it, but this is the easiest way, right? So all the pods that we wish them to use the Egress Gateway, they have to have these 2 labels, right? So class MediaBot and org umpire. And all the workers that we wish them to be Egress Gateway, they should have this label here. So Egress node true, right? So up to now, we don't have pods and we don't have nodes with Egress Gateway. So let's create the pods. So basically, we would create 1 pod on this worker here, worker 0, and 1 pod on this worker here, worker 2, right? So in order to create the pods, let me show you very quickly. So basically, clear. So demo screen. Yeah, so as you could see here, we have like 2 pods. We have pod 1 that is called MediaBot worker 0, which is basically just a net perf, right? And I will force it to work on worker 0. I will force it to run on worker 0. And another pod, which is quite similar, but I will just force it to work to run on worker 2, right? So let's see the creation in real time. This is the beauty of Lens. So kubectl create. And now we should see the pods being created in real time. You see here. So they are green, meaning that they are up and running, right? So let's exec into these pods. So I could exec with the kubectl, or with Lens, I just hit like exec and I go inside this pod. And I do the same thing with pod number 2. I hit exec and I go inside this pod. So now I am in pod, which is on worker 0. And here I am in the pod, which is on worker 2. So what happens if I try to reach my database? So let's try it. So let's go to the pod, which is on worker 0, and I try to reach my database, meaning that I am here at the .26, and I would like to reach this IP, the .83, which is my database. Let's try that. So curl HTTP 10.0.101.83. Yeah. So now, so let's repeat that multiple times. You see, we could basically see that in our VM, we have the traffic which is coming from the .26, right? Which is here. Let's do the same exercise on worker 2. So if we do curl HTTP, so 10.0.83.101.83. So our database, yeah, we see here that we have traffic which is coming from 65. So this is totally not secure, meaning that we don't have any kind of security here. All the Kubernetes cluster could reach, all the applications could reach the database, and this is not what we want. So now let's try to secure. So let's say that we would like to receive the traffic only from the IP.74. So let's add a security group. So if I go to my OpenStack, to the VM3, the DB3, as you could see here, so I just need to add security group. So I remove the default one, and I authorize only worker 1. Save. So now, so if we do the test again, so what we will see is that, so let's try it. So let's connect on pod, which is on worker 0. Nothing happens. It has been silently discarded. If I go to worker 2, nothing happens, meaning that if I show you here in this picture, what happens is that from the 65, it is going to the VMDB3, but it's been blocked by the security group of OpenStack or by your firewall. So now, what shall we do? Thanks to Cilium, we will activate Egress Gateway here, and we will be sending traffic from worker 2 and worker 0 through worker 1. And here in this firewall, it authorizes only traffic that it is coming from worker 1. So let's do that. In order to do that, so basically we need to activate the label. So as you could see here, so worker 1 egress node equal true. It is activated. So let's see that it is activated correctly. We go to the worker 1. We see the label here, right? Worker 1. And now if we test again, so we curl, yeah, we see that the curl is coming from 74. We go to the worker 2, we see that the curl is coming again from 74, meaning that all the workload is being redirected to 74, and it is being going through this egress gateway. So basically, this is a secure way, meaning that it is deterministic, as explained by Jas, and we know exactly where the traffic will be coming from. It will be coming from this specific egress gateway, which is authorized, meaning that we have our applications that are having the right labeling, that is sending them to the right egress gateway, and we could filter it out. So yeah, this is the end of the demo. So just to recap what we have done so far. Yeah, so basically just explained you the limitations that we had today. Basically, it's very rare that we have a company having only Kubernetes. Usually company, they evolve from servers to VMs, and from VMs to Kubernetes, and they still have servers, VM, and Kubernetes. And therefore, yeah, you have some challenges in order to still filter all the needed workload to your DBs. So just explained you as well, so the egress gateways and how they can overcome these challenges. And finally, basically, I did the demo for you. So it's very easy to be set up. So basically, you just need like some virtualization work. YAS could be like OpenStack, could be AWS, could be like ESXi that you install locally on some nuke or something like that. You need the Kubernetes, you need Cilium, and if you wish to have like something cool, you may need LAMPS. Otherwise, you could do it with kubectl. So as a conclusion, so basically, yeah, so if you wish to continue using like zero trust model, yeah, you have to go somehow to Egress gateways in order to secure the traffic between Kubernetes and your legacy workload. Why? Because the default network the default network policy, as explained by Jas, could be used, but it has lots of limitations, right? Meaning that this Egress gateway is overcoming this kind of limitation. This would also help you to not run into this like endless discussions with the CISO and this security team, because basically you will have the same flow matrix that will be secured on your firewall. It's just that you are moving the traffic from legacy to Kubernetes. You will have the same rules. And also one final thing is that today you have seen Egress Gateway with Cilium, but of course you have like hundreds of ways to establish the Egress Gateway or communication to legacy. You could do it through service mesh. You could do it through, for example, another Egress Gateway provider like Calico Enterprise. You could do it with like other ways, right? So yeah, so thanks a lot. So one more thing before to move to the questions. So basically, next time we will have on June 26 and on July 11 other talks that are very, very interesting. The first one is how to use Crossplane in order to have unified cloud service provision and management, and we will show you as well how to use Kubeflow and how interesting it is.
Thank you for attending another one of the Mirantis Labs Tech Talk sessions. Hope you've been finding them useful. As Waseem said, we do have some more coming up in the near future, Crossplane, and I forgot the other one, AI, something to do with, TensorFlow, I think it was. So yeah, please do join us on those, spread the word. We look forward to chatting to you all again soon. Take care. Enjoy the rest of your days, and Federico, we will be in touch.